All right. Today we are diving deep into the single most complex thing in the known universe, and it's right between your ears. We're going to talk about your brain. We'll explore how this incredible biological hardware is running the software of your entire life. Your thoughts, your feelings, your personality, all of it. So, to kick things off, let me tell you about a woman named Carol Poe. When she was 60, she had this procedure. It's called deep brain stimulation. And what that means is doctors put these tiny little electrodes deep inside her brain. With just a little zap of electricity, they could literally turn her hunger on and off, just like a light switch. In her own words, it was amazing going from feeling hungry to feeling full. And that just has to make you wonder, right? How on earth can a tiny burst of electricity completely change something as fundamental as your appetite? I mean, what's the machinery inside our heads that makes that possible? Well, in Carol's case, that little jolt of electricity was aimed at a specific spot called the hypothalamus. Think of it as the brain's command center for hunger. It's this incredible direct link between brain activity and our actual behavior. Okay, let's dive into that. First up, the brain on a diet. All right, next up, we've got section 2, your body's wiring. Because to understand how any part of the brain works, you really have to go microscopic and look at the fundamental building blocks. Get this, you were born with over 100 billion of these specialized cells. 100 billion. To put that in perspective, that's more than all the stars in the Milky Way galaxy. And this massive network is the foundation for absolutely everything you will ever do, think, or feel. And this is the star of the show, the neuron. A neuron, a nerve cell, is basically a tiny little messenger. Its entire job is just to transmit signals. They're the little guys that make everything happen, from a simple twitch of your finger to your most complex ideas. And the way they work is actually pretty straightforward. Think of it like this. A message comes in through these little branches called dendrites. It goes through the main cell body, the soma, and then whoosh, it shoots down this long cable called the axon to be passed on. It's a total one-way street for information. Now here's a really cool part. When a neuron decides to fire, it doesn't mess around. It's what's called the all or none principle. That electrical signal, it's called an action potential, it either fires at full 100% strength or it doesn't fire at all. There's no in between, no kind of firing. It's either on or off. Which brings us to our next section, the brain's chemical language. So we've got this electrical signal zipping down the neuron, but what happens when it gets to the end? There's a tiny gap to the next neuron. So to cross that gap, the brain actually has to switch from an electrical language to a chemical one. And here's how that magic happens. First, that electrical impulse reaches the very end of the axon. That causes the neuron to release these special chemicals called neurotransmitters. These little guys then float across that tiny space. It's called the synaptic gap, and they plug into the next neuron, kind of like a key fitting into a lock. And if enough keys turn in their locks, boom! It kicks off a brand new electrical signal in that next neuron, and the message keeps right on going. And these chemical keys, well, they're unbelievably important. And getting the balance right is everything. Take dopamine, for example. It's all about pleasure and movement. Too little, and you see issues like Parkinson's. Too much is linked to schizophrenia. Then there's serotonin, which handles mood, sleep, hunger. An undersupply there is often linked to things like depression and anxiety. And GABA. Think of GABA as the brain's main brake pedal. It's inhibitory. If you don't have enough, things can go haywire, leading to anxiety or even seizures. All right, that brings us to section 4, fight, flight, or freeze. So we've been looking at these tiny cells, right? Now let's zoom way out and see how all this wiring comes together to literally keep us alive in an emergency. Okay, so think of your body as having two systems that are always working against each other. First, you've got this sympathetic division. This is your body's gas pedal. It's the whole fight or flight thing. When there's a crisis, this system floors it. Your heart rate goes up, you're ready for action. But then you have the parasympathetic division. This is the brake pedal. Its job is to rest and digest. It calms you down after the threat is gone. They're in this constant tug of war to keep your body perfectly balanced. Okay, for our last section, let's take a grand tour of the brain. Now that we have the building blocks down, we can look at some of the major structures and see how they create our entire experience of the world. And the best way to do that is through some really incredible human stories. First stop on our tour, the thalamus. The best way to think of the thalamus is as the brain's main sensory switchboard, like an old-school telephone operator. Pretty much all the information coming in from your senses, everything you see, hear, feel, and taste, it all has to pass through the thalamus first. It gets routed from there to the right part of the brain. The only one that gets a free pass? Smell. That goes its own way. Okay, now we're going deep inside the brain to a structure called the hippocampus. Fun fact, it's named after the Greek word for seahorse, because that's kind of what it looks like. And its job is one of the most important of all. It's the brain's memory maker. It's what lets you form new long-term memories. And the reason we know this with such certainty is thanks to one of the most famous patients in the history of science. This is Henry Mullison, better known as HM. Back in 1953, to treat his severe epilepsy, surgeons took out his hippocampi. And the good news is, his seizures stopped. The terrible news? He could never form a new memory again. For the rest of his life, he was stuck in the present moment. He couldn't remember what he ate for lunch 5 minutes later. He'd meet the same doctors day after day for decades and never remember them. His tragic case was the absolute proof that the hippocampus is where new memories are born. Right next door to the hippocampus is the amygdala. This is the brain's fear and emotion detector, and it is fast. In fact, sensory information hits your amygdala before it even gets to your conscious brain. That's why you'll jump out of your skin when you see something that looks like a snake on a hiking trail, and only a split second later do you realize, oh, it's just a stick. That's your amygdala, a super fast, life-saving alarm system. And our final stop brings us to the front of the brain, to the command center, the big boss, the frontal lobe. This is where all the high-level stuff happens. We're talking planning for the future, making tough decisions, and maybe the biggest one of all, your personality, who you are. And one of the first big clues about this came from a really gruesome accident way back in 1848. There was a railroad foreman, Phineas Gage, and an explosion sent a 3-foot-long iron rod straight through his head. It completely destroyed a huge chunk of his left frontal lobe. The crazy part? He survived. But the Phineas Gage that came back was not the same man who went to work that day. See, before the accident, Gage was known as this responsible, well-liked guy. Afterwards, he was impulsive, used horrible language, couldn't stick to a plan. His own doctor wrote that the change in his mind was so marked that his old bosses couldn't even give him his job back. Phineas Gage's story was the first real piece of evidence suggesting that our personality, our very self, isn't some ghost in the machine. It's physically located in the tissues of our brain. So, let's just recap. We started with a single neuron firing an all-or-nothing signal. We saw how chemical messengers have to leap across a tiny gap to keep that message going. And we zoomed out to see how massive brain structures let us remember our past, feel fear, and even shape who we are. It all boils down to this one powerful idea. Your brain's biology is the physical hardware, and it's running the incredible, intangible software of your life. And all of this leaves us with one last big question to chew on. Think about it. Carol Poe's hunger just vanished with a little bit of electricity. HM's ability to make new memories was surgically removed. Phineas Gage literally lost a part of his personality. All of their stories point to the same thing. So, if our biology is what builds our reality, then who are we when that biology changes?